For the differentiation of exponential functions, there are also two formulas that we need to be familiar with, but first we recall that for a function in the form y equals a to the power of x, that is what we call as an exponential function, where a there is the base and x here is our exponent. So this time the base is a constant, a is greater than 0, and it must also be not equal to 1. And x there is what we call as the exponent. But if the base is the natural number e, so we can write that as y equals e to the power of x. So for these two exponential functions, so we have two formulas that we can use to differentiate. So the derivative, if it is in the form a to the power of u, remember that the exponent there is u, and u is a differentiable function of x. All we need to do is to copy the given a to the power of u, multiply it to the natural log of the base a, and then again multiply it to the derivative of u with respect to x. If the exponential function has a base e, so the derivative with respect to x of e to the power of u is simply equal to, you copy e to the power of u and then multiply it to the derivative of the exponent u, so that's the derivative of u with respect to x. So only two formulas. Copy the given, multiply with the natural log of the base a, and then multiply it to the derivative of u with respect to x. If the base is the natural number e, we have copy the given e to the power of u. If we write ln of the base e, ln e is just equal to 1. Ln e is just equal to 1, so that's why we just automatically write the derivative of u with respect to x. So for example, we want to find the derivative. We want to find the derivative of the function y equals 4 to the power of 2x. So in solving the differentiation or finding the derivatives of exponential functions, we will be able to use here the laws of exponents in algebra. So using the formula, the derivative dy dx is equal to, we just copy the given, 4 to the power of 2x, and we multiply it to the natural log of the base 4, and multiply it to the derivative of the exponent. So the exponent is 2x, so its derivative is 2. So that's 4 to the power of 2x times 2 ln of 4. Remember that we cannot multiply these two. Okay, so and then using the laws of logarithm, remember that a ln of u is equal to ln of u to the power of a. And also for the laws of exponents, if you write a to the power of bc, that is just equal to a to the power of b quantity to the power of c. So we're going to use those laws. So 4 to the power of 2x can be written as 4 squared to the power of x. And 2ln 4 can be written as ln of 4 raised to the power of 2. So 4 squared is equal to 16 to the power of x, and then ln of 4 squared again is equal to 16. So that is our derivative. But also, starting from y equals 4 to the power of 2x, as early as this part here, we can just write this as 16 to the power of x. And then we can just differentiate. Find the derivative dy dx is equal to, copy the given 16 to the power of x, and then take the natural log of the base 16. And the derivative of the exponent x is just equal to 1. So we still get the same answer either way. All right, another example. We want to find the derivative of y equals e to the power of sine x. So then the base now is the natural number e. So its derivative dy dx is very simple. We just copy the given e to the power of sine x and then multiply it to the derivative of the exponent sine x, which is cosine x, and that's it. We cannot simplify that any further. So that is our derivative. Let's have more examples. Let's find the derivative of y equals 1 plus 2 to the power of x divided by 1 minus 2 to the power of x. So it's a fraction. It means to say that we are going to use the quotient rule. So dy dx, write the fraction bar first, copy the denominator 1 minus 2x, 2 to the power of x rather, and raise it to the power of 2. In the numerator, we copy the denominator first, 1 minus 2 to the power of x, and multiply it to the derivative of 1 plus 2 to the power of x, which is simply 2 to the power of x, ln of the base 2. The derivative of this is this. To continue, minus, we're just going to extend this fraction bar right here. We are going to copy the numerator 1 plus 2 to the power of x and multiply it to the derivative of the denominator, which is negative 2 to the power of x ln of 2. So this time the derivative of 1 minus 2 to the power of x is this. So next is we are going to simplify. We're going to simplify our numerator. Let's just copy the denominator right here. 1 minus 2 to the power of x quantity squared. So that's 2 to the power of x ln of 2 minus 2 to the power of x times 2 to the power of x. So that's 2 to the power of x quantity squared, right? Ln of 2 plus, it's a plus right here because it's a minus and a minus. So plus 2 to the power of x ln of 2. And again, it's a plus. That's 2 to the power of x quantity squared ln of 2. And as we can see, we can cancel this 2 to the power of x quantity squared ln 2. So we're going to cancel that out. So what's left in the numerator is 2 times 2 to the power of x ln of 2 divided by 1 minus 2 to the power of x quantity squared. Now remember, if you are writing 2 times 2 to the power of x, it is wrong to multiply it like that. Remember that if you're multiplying powers with the same base, you're going to add their exponents. So 2 to the power of x is equal to 2 to the power of x plus 1. Because you're adding their exponents. X here is the exponent and the exponent of 2 here is 1. So it's 2 to the power of x plus 1. Okay? So it's either you write it like that, 2 to the power of x plus 1, or it's either we write it as 2 to the power of x plus 1 here, ln 2, divided by 1 minus 2 to the power of x quantity squared, or we can write this as, instead of 2 to the power of x plus 1, we can write this as, let me rewrite this. This is 2 to the power of x ln of 4 divided by 1 minus 2 to the power of x quantity squared. So that is our derivative dy dx. Now why is it ln of 4? Because in this part right here, we can write this as 2 ln of 2. And 2 ln 2 is equal to ln of 2 squared, and ln 2 squared is equal to ln of 4. That's why we have ln 4 right here. Okay, so that's laws of logarithm and exponents in combination. So you always have to remember the laws of logarithm and exponents if you're dealing with exponential and logarithmic functions. Okay, fourth example, we want to find now the derivative of y equals x to the power of e to the power of x. So as you can see here, we have an exponential function. We have a variable in the denominator and still a variable. I mean, variable as a base, variable as an exponent. So what we can do here is to use logarithmic differentiation. So we recall for the logarithmic differentiation, the function is given in the form y equals u to the power of v. And remember that we can find the derivative dy dx by simply copying u to the power of v and multiplying it to the derivative with respect to x of v ln of u. So in our case here, the given y equals x to the power of e to the power of x, our u is x, and v here is equal to e to the power of x. And so applying the formula for logarithmic differentiation, remember that if you forget the formula, this formula for logarithmic differentiation, you can just follow the three steps, wherein you take the natural log of both sides and then simplify using the laws of logarithm, and then eventually find dy dx. So our derivative dy dx is equal to, we are going to copy the given x to the power of e to the power of x, and we multiply it with respect to x. We multiply it to the derivative of e to the power of x times, okay, that's v, and then ln of u, which is ln x. So as you can see there, that's a product of two functions. So we have to use the product rule. So again, copy x to the power of e to the power of x. Remember to really write it correctly, because sometimes you have the tendency to write the exponents beside each other. So that's very wrong. So be very, very careful in writing the exponents. Make sure they really look like exponents. They are smaller. Okay, so times, copy e to the power of x, multiply it to the derivative of ln x, which is 1 over x. That's the derivative right there. And then plus, copy ln x, and we multiply it to the derivative of e to the power of x, and the derivative of e to the power of x is simply e to the power of x. Okay, so as we can see there, common term is e to the power of x, so we are going to write that as x to the power of e to the power of x times e to the power of x. So remember that again, the base here is e, the base here is x, so they have to be the same size right there. Okay, we factor that out, times 1 over x plus ln of x. So we can actually combine the two fractions right there. You can leave it like that. Or we can combine the two fractions. So x to the power of e to the power of x times e to the power of x times 1 plus x ln of x divided by x. So we just combine the two fractions. And then because we have a base here e and a base here e, so we can combine that. So we can write that now as x to the power of e to the power of x minus 1, okay, loss of exponents, times e to the power of x times 1 plus x ln of x. That is our derivative dy dx. Okay, fifth example rather. We now find the derivative of y equals. Okay, y equals, or rather, let's change that. Let's find the derivative of e to the power of x plus y equals the natural log of x over y. So this is an implicit function. So we're going to perform implicit differentiation. The derivative of this term here on the left side is we simply copy the given e to the power of x plus y and multiply it to the derivative of the exponent x plus y, which is 1 plus y prime. Equals, we differentiate the left side. The derivative of ln of u is 1 over u. Our u there is x over y. And we multiply it to the derivative of x over y, which is, we copy the denominator, raise it to the power of 2, and then in the numerator we copy the y, multiply it to the derivative of x, which is 1, minus copy x, and then y prime, the derivative of y. So simplifying, this is y minus xy prime. As you can see here, this is y and this is y squared, so you can just cancel this one. You have 1 right here, so the denominator now is xy. Okay, and then here on the left side, we have e to the power of x plus y times 1 plus y prime. So let's cross multiply. This is xy e to the power of x plus y, okay, plus xy y prime e to the power of x plus y. We just multiplied this here and also this then distributed here. So xy and then this one. So it's this first term right here. And then xy e to the power of x plus y and then y prime. We just distributed it. And then on the other side, what's left now is cross multiplication, or multiplying both sides by xy. So what's left on the right side is y minus xy prime. And then we're going to transfer all the terms containing y prime to the left side. So this one we're going to transfer, and this one we're going to transfer to the other side. So we have xy y prime e to the power of x plus y. This time it's a plus xy prime equals y minus xy e to the power of x plus y. And on the left side, we're going to factor out common terms. Try to see if we can cancel out something. So the common terms are x and y prime. So factoring out x, y prime, we have y e to the power of x plus y plus 1. And on the right side, we factor out y. We have 1 minus x e to the power of x plus y. So simplifying, y prime therefore is equal to y times 1 minus xe to the power of x plus y divided by x times 1 plus ye to the power of x plus y. So there are no common terms, so we cannot cancel out something or anything. So that is now our final answer for the derivative.